All right. So among the best known and also the most important ore deposits are those generated from hot iron-rich fluids called hydrothermal solutions. Hydrothermal stands for hot water. Included in these hydrothermal solutions or hydrothermal deposits, we have things such as deposits for gold deposits in South Dakota, lead, zinc, and silver deposits or ores in northern Idaho, and the silver deposits in Nevada, for example. Most hydrothermal deposits originate from hot metal-rich fluids that are remnants of the late-stage magmatic processes. So they do come from igneous processes. These hot fluids that are iron-rich or metal-rich for the most part have a high mobility and typically flow into small fractures and crevices until eventually they become deposited in the surrounding rock, and then they get cooled and precipitate metallic ions to produce these vein deposits. Many of the most productive deposits of gold, silver, copper are from these vein deposits, mostly of gold and silver, as is the case in the vein deposits of northern Idaho, for example. Another important type of accumulation generated from these hydrothermal activity is called the hydrothermal disseminated deposits. Rather than being concentrated in a narrow dike or vein like we saw in the previous slide, these rocks are distributed as minute masses throughout the entire rock mass. Copper occurs in said manner a lot, actually, as it is the case when it's found in, for example, the Bingham Canyon copper mine in Utah, right next to Salt Lake City, or in Chuquicamata in Chile, or as it was the case in Butte, Montana, where there was a lot of mining of different ores about 100 years ago. Because only about 0.4 or 0.8% of the rock material under which we find these, copper, for example, is only of copper, a lot of the material that is mined is actually wasted. And it is a cause for a large environmental concern what to do with this waste material, which is what happened, for example, in Butte in Montana with the mine tailings from the mining operations which occurred there. So a lot of the mine tailings in Butte actually contaminated the surface water, the groundwater, and the soils around which the mine tailings were. And nowadays we're still dealing with the repercussions from that. The bottom two images that you're seeing in the slide, bottom two to the right, are from Butte's new lake that formed where the main mine used to be, where the main mine site used to be. The lake is quite poisonous, as it has a very large amount of toxic metals remaining from the mine waste and the surrounding walls. So some of these tailings can cause a lot of contamination, not just to the surface water or to the nearby vegetation, but also to the groundwater. So nowadays we know about them, and we're trying to deal with this type of contamination more so than before. So an economically important mineral with an igneous origin is diamond, for example. Diamonds are thought to originate about 200 kilometers at depth, where the pressure is great enough to generate this high pressure type of carbon. Later on, they are basically carried upwards through this pipe, as you're seeing in the pictures there. Although diamonds are considered as gems, they're also very good abrasives and very good for cutting all sorts of materials, because they are pretty much the hardest substance on Earth. And so once diamonds again are crystallized, they are carried upward through the pipe-shaped conduit that you're seeing in the image. And this conduit increases in diameter as it gets closer and closer to the surface. Nearly the entire pipe usually contains this diamonds that are disseminated throughout that rock. And the rock that usually contains them is of ultramafic origin or ultramafic nature. The specific rock that contains these diamonds in a disseminated way is called kimberlite, so you may have heard it. And the rock name comes after a place in South Africa, which is where I think they were first found. So South Africa has the most productive diamond mines, but in Siberia, Australia, and up in the Northwest Territories of Canada, there has also been great success at finding the diamonds. The pictures that you're seeing there are actually from the Diavik diamond mine in Canada, which is where my uncle works for a few years now, for about 15 or 20 years now. Okay, so with that, we conclude Chapter 4 on igneous rocks, and we move on to Chapter 5 with volcanoes and volcanic eruptions. As always, if you have any questions, please let me know, and I hope that the material that we covered was useful and informative.